Okay, so this is now video 197. It's still Friday. Let's make sure Friday. Yep, March 19th. Video number 197. We're working on the Pisces symbol, and I also updated the go live notification. Okay, cool. So this is the last symbol we have to work on. So I have a good idea of what I want to already draw, but we should check the let's close this. We should check the internet. Pisces images. So let's look at images. So we want to know kind of what the there's many different ways we could probably stylize this symbol. So we want to make sure that when we're looking at reference that we understand the most like canonical version, right? So the space between these two hemispheres, or these two kind of curved lines, looks like it's slightly variable from like this symbol here, right? This one here, it's not a perfect semicircle, but it looks like we can get away with the perfect semicircle, and people will know what we're looking at, right? We got to know what attributes of the sign are important and what are not. So, if, for example, this is kind of cut off on the edges. Hey, how's it going? Oh. Crap. Yeah, I'll be back. Food has arrived, so we're gonna work on this when I get back. But food, plate, fork, knife. I gotta get that stuff, so I will be back after I've done that. So let's go break time. Let's start a little timer. And yeah, I'll be right back. Well, not right back, but we're gonna say 20 minutes max. I'll be back. Food, plate, fork, knife. liquor drug now. Okay. So let's get this rolling here. So Pisces symbol, not Pisces symbol, sorry. Yeah, Pisces. Yeah, Pisces is the symbol we're working on. Okay, so let's look at these source files and let's stub everything in and then go from there. So let's go open this with Notepad++. and just copy paste some code here. All right, so this is going to be Pisces. So the first 3 letters of Pisces is PIS. So we'll save this as PIS001.scad. And we're going to do kind of the same kind of stuff for everything, right? So we're just going to create those 2 files that are going to be responsible for creating the SVG graphics. We're going to stub those in right ahead of time. And why are we doing it in this order? I don't know. That's just the order I've been doing everything in. And it seems to be a decent flow, so that's the way we're going to roll. Okay, so now the next thing is we want to open up this cutting file, right? And we want to say, oh, we have Aquarius code. Well, we're going to do all the Pisces code, right? So I'm going to take the Pisces code. And now that we have this, we'll rename the aqua whatever the hex, right? These things are going to be renamed. So PIS, first 3 letters, and PIS, first 3 letters. And then everywhere it says Aquarius, we're going to say Pisces, so P-I-S-C-E-S, Pisces. A little bit hard to spell for me, but we'll get it working, okay? And then cut, paste, cut, paste, cut, paste, all right? Okay, cool. So now that we have that in place, we can close this, and we can start to work on the main file here. So the first thing is, I don't know what we want to do for this, but here, okay. First let's make the constants. So the Pisces constants, the Pisces symbol constants. What's going to go in here, right? Okay, so if we look at this, we have a radius. So imperial radius equals, I don't know, maybe it's pretty big. So I don't know, like 3 or 4 or something. And then Zot Pisces, and then we have a length. We have like a crossbar length, right? So that's a crossbar length, and this is radius of partial circles. So we have these arcs. We're just going to make partial circles for those and call it good. And we're going to take these, though. We're going to take these imperial values, and we're going to use them down here. So we're going to create a section called Pisces code, right? Name it kind of same section divider as the other stuff, but this is for Pisces code. So okay. And in here, we're just going to say, you know, module zotcom Pisces, P-I-S-C-E-S, takes a SBC object, which is for shopbot constants. And within here, we are going to create shorthand variables for these. So imperial radius and imperial length. I'm kind of sick of just call it rad and length, right? Let's not worry about making them that long, right? Let's shorten them as much as possible, right? Imperial, so they're in inches. And then we also have a thickness variable, which we definitely will need. So we're going to steal this thickness variable from here. And the thickness variable is always the same for every single symbol, because we want all the symbols to look very uniform in style. And therefore, the thickness that we draw the zodiac symbol with will be the same thickness for all of the different symbols, right? So that we don't have... So we want everything to look very uniform, right? We want all the symbols to look like they're from the same font set, if you will. Okay, so now that we have that in place, the next thing we want to do is put the debug mode back on. So right up here, we're going to put the debug mode back on so that we can see what we're drawing. And then we also want to call this, right? We want to call this so we can see what we're drawing as well. So Zot SBC. So the reason this is Zot SBC and this is SBC is this is a top-level configuration file that comes with the file itself. But when we're calling this code from another file, it will take a generic SBC object, which may or may not be this SBC object. SBC standing for shot-bot constants. So now that we have that all ready to go, we need to open up the main file and just start hacking away here until we have what we want. So let's go render this, go top view, zoom extents all. Okay, so we have the Zodiac wheel. And we want to put the next symbol in the middle of the circle. In order to do that, though, we have to actually write the code for that, right? Because there's no code. There's just, 3 variable declarations, but there's no geometry yet. So the first thing we want to do is a vcarve inch wheel. And we want to take an SBC constants, and we want the wheel to be the radius. So it's this radius, and then it also has a thickness. So just take that and just see what we have. So F4. And I'm going to guess that radius is hitting this. So this radius is way too big. So we're going to go find this radius in the constants and say, whoa, boy, you're way too big. Maybe 1.5. And actually, that might actually be okay. I changed my mind. Let's put a little breakpoint there. And let's remove some of the breakpoints from some of the older code we were working on. So Capricorn stuff. Okay, there. So now we're going between the 2 pieces of code we're interested in. So, over here, this might be okay. It just needs to be, we need to translate it over a bit. So, let's do integer x, sorry, not integer x, inch x offset, SBC, and do like, 0 minus the radius. Yeah, 0 minus the radius. And just call that good, see where that gets us, and then we'll work from there. Okay, so now F4. Okay. So that might be good, that might not be. I was really hoping that maybe we could... Well, maybe it's okay. Okay, so before we even move this, so here's what we're going to do. We're going to get rid of this... We're going to get rid of the debug wheel for a second. We're going to get rid of the debug wheel because it's just going to confuse us because of what we're currently working on. And we're just going to go F4. And in here, let's get rid of the translation here. Okay, so we got this wheel, right? And we just want to make an arc. And I think it would be nice if the arc was just... well, I don't know, is that too extreme of a curve if we do it that way? Let's go look at Pisces symbols again and see if we can get an extreme arc or if that's too much. So we might need, like, instead of a half circle, we might need, like, a fourth of a circle or something a little bit less extreme. So, right, this isn't exactly a half circle, right? So we might not want to do... Yeah, like... all the symbols we see... Like, this is almost a half circle here. Okay, so it's like a little moon. I got this little moon thing. Yeah, half circle seems too extreme. So I'm thinking... So first of all, let's just cut the circle. Let's cut the circle in a way that we think makes sense. But definitely not a half circle. A half circle is too much. Yeah, with something very abstract and highly stylized, yeah, but by the time we stylize it this much, nobody knows what the heck we're looking at, right? We want kind of the, right, or this is very stylized as well, but we don't want to stylize it that much, right? We want to, yeah, even though we could kind of do this, right? We could do a half circle, but, it's not that common. So I'm thinking if we could get away with it, it would be nice to do like a 45-45 cut of the semicircle, like creating a pie slice where to create this arc, we go from the center of the circle and we go out 45 degrees here, and then we do the same thing down here. We go 45 degrees this way. So if this is 0 degrees, positive 45 degrees, negative 45 degrees, and we make these cuts on that circle. I think that would be the best way to do this. I don't know if 45 is the best number of degrees. We'll just see if it visually looks good, right? So what we're going to do here is we just need to make a polygon. So first of all, difference, right? We got to make a difference and a union. So we're going to, this will be the additive geometry section. Okay. And then this will be the subtractive geometry. So we already have the additive geometry. And then we want to make a polygon. So we need a polygon and the points equals something, something, something. We don't know yet. But we need like a triangle. We need a big triangle. And it's actually not going to be a difference. It's going to be an intersection. It's going to be an intersection of this shape with some type of triangle we're going to draw, right? Some gigantic triangle. And so the first point is just going to be 0, 0. It's going to be in the center. And then the next point, we want is going to be in here, and then we have another point, right? We just need a triangle, right? We just got to take out like a pie slice shape from here. Okay. So I don't know where we want all these commas. Points. Okay, is that correct? Did we screw any of this up? Let's see if it crashes, right? Okay, yeah, because there's nothing in here. That's fine, that's fine. We just want to get something basic in here. Okay, so, oops. So in here, let's just do these. So from the previous point, right, which is 0, plus the cosine of some type of angle, which is going to be 45 degrees, times some type of distance, which is going to be, we could do the radius times something or other, radius times 3, if we really want to make sure that we're good, like we're in the safe zone. And then we have 0 plus the sine, 45 degrees, times the radius times 3. Right, so the only difference for the x and y is that the x location of the vector, the x magnitude is the cosine of the angle, and the y magnitude is the sine of the angle. Now, that's the way I've learned it. I think you could... This is for a circle that starts... 0 degrees is over here, and then it goes counterclockwise, right? If you swap sine and cos, you'd end up with a circle that goes... I believe you end up with a circle that goes in the other direction. It either goes in the other direction or it like has a different origin point. I don't know exactly what it is, but I don't need to know because I just remember that the origin 0 degrees is here, and then we go counterclockwise if we do cosine and sine for the parametric circle formula. Okay, so let's take this, and then the next thing we want inside of here is this is a positive 45. So make a note that this is positive 45. So we're going to go here, and actually we want to start off with negative 45 because we want to draw our polygons with a counterclockwise winding order, just because that's the order in OpenGL in which you have a front-facing polygon. Now, it doesn't matter in this code, but it's good to just keep kind of very consistent habits, right? The less things that are arbitrary, the better. So, even if it's a silly reason for not being arbitrary. So, doing this, we got nothing. Like, we got nothing. And the reason we have nothing is because this radius is in terms of imperial units. And so we need to convert that. So this so we have to go find the conversion factor. So this imperial native right here, right? That is the conversion factor to convert an imperial unit to native internal units. So we'll put this at the top of the file. And we'll use this conversion factor here, right? So all of this stuff needs to be converted, right? So when we're looking at this, we need to take all of it, all the formula, and just times it by that, right? And so, same thing here. Now, we don't have to worry about 0, 0, because it's, 0 is, right? If you times it by something, it's still 0, so that we don't gotta worry about that. Okay, so F4, let's see if that, there we go. So now, we have this arc, and I kind of like that, right? So 45 and a 45, the reason I want a 45 and a 45 is just because, well, first of all, fourths are nice, and second of all, just a nice 45-degree angle is nice, right? Like, we're trying to, when you think about a nice design, you want things to line up, you want things to snap, you don't want to use a nice clean design reduces choice. I don't know how to describe it, but snapping to like 0, 45, 90, 90, 145, no, 135, 135, 180, something like 240, 215, 270, right? Snapping to snapping your angles to like evenly spaced intervals. This is just going to make for a better design. I don't know how to describe it. Structure, right? We want to impose structure, and the way, if you think of structure, what does structure mean? Structure means imposing constraints and limiting choices, right? That's what structure is. Imposing constraints, limiting choices, limiting possibilities. And that's how you're going to get a solid design, right? You get a solid design from actually eliminating possibility, which can that can seem kind of contradictory when you think of art, because you think art is like, oh, any boundless possibilities, right? Nope, not the case. Okay, so do not reload that. That's just OpenSCAD trying to screw with our file, and it'll screw you over if you do that. Okay, so now we have this radius, right? And we have this arc, and from here to here is the radius, right? So if we want to put this back on the center point, we have to subtract the radius, and then we want to go some distance, right? So we're going to go IY SBC minus SBC comma 0 minus the radius, and just move that back onto the center line. Okay, and then that's X. Sorry, my bad. Still get my X's and Y's confused. Okay, so now that it's on the center line, we got to figure out how far back to move it, right? So how far this way do we want to move it? And I don't actually know how much we need to do, but I'm thinking it should be somehow based on this length variable, right? So I'm thinking, in terms of the length variable, it would be nice just to divide things into thirds. So to divide it into thirds, we're going to do SBC, and we're going to do 0 minus length divided by 3 divided by 2, right? Because it has to go, we're going to have 2 of these, right? So we divide the length into thirds, and we want to place this at one of those third points, but we go halfway this direction, halfway that direction. I don't know if that makes any sense, but trust me, it'll make sense. So F4. That is a lot less drastic than I thought it would be. But the next thing we want to do is just mirror this. So we're going to mirror this horizontally. Okay. And then we just want to, we got to put in the crossbar, right? So the crossbar is going to use this length here, right? So for that, we just use a V-carve inch pocket, use the SBC variable, and we use the length and the thickness for the X and Y axis, and then 0 for the thickness, which is kind of odd, but maybe I need to rethink how I decided to do that. So the crossbar there. So here's what I'm talking about, the thirds, right? So we go halfway, half of a third this way, half of a third this way to get the center points of these intersections, and now where the intersections happens are at thirds. So here's 1/3, here's another third right here, and another third of this crossbar line. Okay, so now that we have that kind of position in place, and it looks pretty good, the next question is, did we make it an appropriate scale? So we're going to put the wheel debug code back in for a second, and we're going to see if that looks good. And we're going to say, you know what, that's very close to looking good, but it's just a little bit too big. It's like, this is just a little bit too close. So we're going to look at this code, and we say, oh, we have this kind of like, the radius is 3. So what about like 2.8 or something, right? We're really close. It's just a little bit too big. So that looks a little bit better. That's a little bit better because we're a little backed off. We want like 1/4 of an inch roughly between there. So that looks pretty good. I like that. So now that we have that in place and we're satisfied with it, the next part is to just turn off the debug code, right? And say, okay, we want to ship this, right? That's good as it is. Let's ship it. So we're going to take this, we're going to make that 0, and go F4, right? And then we're going to go down to the code that we're looking at, and we're going to remove this, right? And this file is going to be completely empty in terms of graphics, right? Because this is our utility file. It shouldn't actually render anything, right? It's just a file that's included by other code. Okay, now what we can do is we can go into the main cutting files, and we can go find that Pisces file, right? So here's the Pisces file. Let's go open it up, and we're going to get the same exact graphics out, but it's just important to verify that this file is indeed going to make what we think it's going to make, right? And then we're going to go File, Export as SVG, and this is going to be Pisces1.svg. Save that. We're going to close this one, and we're going to open the second one. So the second one is just the locator pins. So these are just the locator pins for the bottom of the table. Export as SVG, and then this is Pisces02.svg. Okay, save. Okay, so now that we have this, the next thing is just taking a screenshot of those vectors we just rendered and putting it into our like little archive. So let's refresh the file system with F5. And this little thing right here is what we want to look at. So let's open this up, and we're going to take a screenshot. We're not going to worry about a professional screenshot. We're not trying to crop it or make it perfect. We just want enough information to see the whole symbol, right? Just the whole symbol. It's for our uses, just to have an index of everything that's in this project, right? So now that we have this, we'll name it as Pisces. So Pisces.png, right? Okay, so now that we have that, let's close this, and let's look over what we have so far. We should have all the symbols now, right? We should have all the zodiac symbols, so we should just count them. So we should be 12, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got all 12 zodiac symbols are now done. So we did it. Hooray. That took forever. That was multiple days of work. But the thing is we wanted the reason this took so long is because we wanted every single symbol to be geometrically perfect, right? And that just resulted in things taking a lot longer than we wanted them to. But I'd say that, you know, this looks pretty good, right? Some of the symbols are kind of guesswork, but in general, pretty good job. I think this is good. Okay, so let's close this. And let's commit our work, right? So git bash here. And then also maybe we should work on a design that has all of the symbols and maybe like a little sun in the middle, right? So I don't know yet. So git status and git add dot git commit dash am git commit dash am ps the Pisces is done, and then we'll go push this up to our personal repo, and then I don't know what we'll do. We'll move on to something else, or I don't know. Git status. And then we'll do a git push. I don't think we did a git push. Git push. Okay. So we have these symbols. I'm sure like people are selling plenty of these kind of things on Etsy already. I don't know what I could do. So Etsy zodiac symbols, right? But the more things we have out there, the better, right? So right, like right, so these are right interesting. So I'm just looking at what is kind of like already on the internet. And we haven't made anything kind of like, we haven't really stylized it, right? Like some of these are very stylized and kind of like, this is very cursive-y, right? Which is kind of nice. And 1,771. So I think people are receptive to that cursiveness, right? So it might be good to download this, right? To buy this and download it for the purpose of seeing how they structure their files, right? So they already have a good listing, right? Or they have all these kind of things here, which is awesome. But the thing is, so this is a really nice listing, right? It's put together very well. So the other thing is like, what is it about this bundle, right? Like, what do the actual source graphics look like? How are they structured, right? Knowing how those are structured might be important to creating a quality download ourselves. Right? Like, what makes, well, first of all, the shop has a whole bunch of downloads. What makes it better than, like, this? Okay, so if we look at this, one thing I see is a lack of structure, but look at that, 120,000 sales, right? So, but all these things have very nice kind of like, very, cursive-y kind of, kind of writing, right? A lot of the stuff I'm seeing here. Let's put that in our list of stuff here. So making a download like the Zodiac signs download, right? If we can just get a listing where we just, you know, hell, just make it $1, right? 80 cents per download, as long as if we got a lot of, like this many sales, right? They're making 80 cents per download because it's 20 cents to list, right? Well, what does that give us, right? So let's just crunch the math here, right? So this, right, times 80 cents, let's say $0.8. So that is $96,000. Yeah. So I mean, I'm not saying that I can make a listing that popular, because I mean, I'm sure there's a lot of extra work that has to be done. But getting this in positioned in a way where we can have it getting the files in a way that is going to be helpful to people is going to be of utmost importance. And so, oh, this is kind of like more the kind of designs I did, right? More bold kind of designs. And so what I might want to do is next is like these kind of designs here, like it has the constellation kind of designs. I might want to do my own version of this. I don't know exactly if this is, so we'll have to read up more on astrology, but doing this would be kind of, this is going to be really hard to do in OpenSCAD, right? Because it's like, look how detailed that is, right? But maybe once we're done doing kind of this kind of design, these kind of designs, we might want to tackle this and figure out how to do this kind of art, but completely in math, right? Like, how would we do this completely mathematically? And I think that's going to be like a big challenge, but we could try to tackle that in OpenSCAD and figure out how we would geometrically create all of these, right? Because, yeah, so let's see. I love these, but the sizes are not consistent, and most are pretty small and cannot be used on a large scale. Great for smaller work, though. So if we could make, so because we're defining all of our graphics in terms of pure math, we could actually sell the original source code used to create it, right? But we might want to hold on to that for ourselves, just so that people don't have that much of an edge on us. But once our code's out there, it's, you know, other people could use it, right? So it's a double-edged sword, right? So if I control the code, then I can, you know, make the graphics to any size they need to be, right? So keeping the code for myself and just saying, hey, if you need any size, I can get it to you. Let's just read more of these reviews. Great customer service. So yeah, we might as well kind of try to figure this out, right? To make something like this. So this might be the next kind of thing we want to work on, is like kind of constellation kind of zodiac symbols, since we've already worked on the others. So zodiac signs download 03. We just need to do whatever we can to okay, but we need to do whatever we can to get something ready, right? So we already have what we need ready to make like a table. But the idea is, like, why not just sell the vector files? Because that'll just be easier to do, right? Now I'm going to guess that, you know, doing this is, like, I really like how this has this, they kind of template it with this star, like all the symbols with these kind of whoop things, right? That makes it really nice. But yeah, just putting everything in, oh nice, they put it in like a little, is this like an Inkscape file? What is this? So yeah, putting in an Inkscape file so that people can, yeah, so I mean, The terms are nice. I should probably also make sure I have these kind of terms. But I can also include the videos of how I made these, right? So let's stop this video because we just did the Pisces symbol. Let's stop this video, start a new one.